Hi everyone, very good morning to all of you. Today we are going to discuss about Motional EMF. It is also nothing but similar like our previous topic, that is induced EMF. So let's say what is induced EMF? So induced EMF is nothing but when flux changes, then EMF will induce, that is rate of change in magnetic flux, that is called induced EMF. Then there is a corresponding current called induced current, that is induced EMF by resistance. Now similarly, what is motional EMF? In the presence of external magnetic field, when you consider, suppose this is a frame and a wire of length L moving with a velocity V perpendicular to its length, perpendicular to magnetic field, then EMF induced across its length is B L bar cross V bar, nothing but BLV sin theta. Here theta 90 degrees, so epsilon equal to BLV. This is what the motional EMF. Here also, to understand, we are considering a U-shaped frame and one wire is sliding over it, so that as the rod is moving, flux linked with the loop keep on changes. As flux changes, then there is some induced EMF and there must be one induced current. But when you consider only rod, single rod, due to the movement, there is a magnetic force acting on the charges inside the wire, so that they move towards the ends, so that the potential difference is created, and it is due to the motion of the rod. That's why we call it as motional EMF. Now, in the same case, when you consider, like in the presence of external magnetic field, when a rod is moving with a velocity v, then epsilon equal to BLV, then the corresponding current equal to BLV by R, then it experiences a force ILB, nothing but B square L square V by R. Then the power equal to force into velocity, that is B square L square V square by R. This is what the power dissipated, because due to the velocity EMF will induce, so that there is one current, and so that there is some current develops, due to that an opposite force will develop. The force develops in the opposite direction, so that velocity try to decrease. So to maintain the same velocity, we need to apply this much of power. So that is what we are trying to explain here. Now based on the simple formulas, the questions can come and we need to understand from the examples given below. Let's see the examples. Simple questions will come. Now sometimes they'll also ask the question based on, like if there is a rod rotating with an angular velocity omega, then across its center and across its ends, the EMF induced is half B omega L square. So this is the EMF induced across its ends in the presence of external magnetic field. This is what EMF induced. Suppose if it is rotating about the center, then the EMF induced across its ends is 0. So depending upon the question, or sometimes they'll ask like one disk is there. Now disk is rotating about its axis with omega angular velocity. Then between center and periphery, epsilon is half B omega R square. Here it is like a combination of rods, each of length equal to radius. So similar formula will come. So sometimes they can ask based on the question like this. Now, one more thing also here you need to understand. In case of this, if there is a wire of any random shape, if it is moving with a velocity, now you have to consider the effective length of the wire so that the induced EMF will become BLV. That is also useful. Please try to remember it. Now, to find the direction of EMF, you keep your right hand like this finger should be along the magnetic field and this thumb should be along the velocity. Then perpendicular to this is the direction of current like this downward. If it is like this upward. So this finger should be along the direction of field and thumb should be along the velocity. Then perpendicular to this palm, the direction of induced current they will give due to induced EMF or motional EMF. Now let's see the examples. A conducting rod of unit length moves with a velocity of 5 meters per second in a direction perpendicular to its length and perpendicular to a uniform magnetic field of magnitude 0.4 Tesla. Now velocity is 5 meters per second, perpendicular to its length and perpendicular to magnetic field. Then EMF induced means BLV. So that the EMF will become 0.4 into 5 into length, unit length. So length is 1 meter. 1. So epsilon will become 2 volt. Very simple question, direct formula based question. Next question. Figure shows the top view of a rod that can slide without friction. The resistor is 6 ohm and a 2.5 magnetic field is directed perpendicularly downward into the paper. Let L equal to 1.2 meter. Calculate the force F required to move the rod to the right at a constant speed 2 meters per second. Now, the very first thing is they have given the resistance as 6 ohm and magnetic field as 2.5 Tesla and length is 1.2 meter. Now calculate the force required to move the rod to the right at a constant speed. So force formula is what? B square L square V by R. Resistance given, L is given, B is given and the speed they have given as 2 meter per second. Then you can find it easily. Now at what rate is energy delivered to the resistor? So power they are asking. So what is the power formula? B square L square V square by R. Just. So this way you can find, they can ask question based on EMF or current or force or power, anything they can ask. So just try to understand and try to solve the question. Now here a square loop of side L being moved towards right at a constant speed V as shown in figure. The front edge enters the magnetic field B at t equal to 0. The width of field is 4L. Sketch the induced EMF versus time graph. See, as it enters first, only this side is inside the magnetic field like this. Like this. And for this one, induced EMF 0. For this one also induced EMF 0. Because velocity is parallel. Only induced EMF will be there along the vertical sides. Now, when it is inside, completely inside, so the change in flux is 0. So the complete EMF is 0. Now, when it is going out, then there is some induced EMF across this one. So that way, when you consider the induced EMF, first there is some induced EMF. Now the flux across that increasing. Now it will become 0. So they are asking the variation of with the time. So with the time, so as long as it enters, until it enters completely inside, the induced EMF is constant across this end. And then it becomes 0 completely. as long as it is inside. And the moment it started coming out, the EMF will become same value but opposite, because now the flux keep on decreases. As it is entering, flux increases. As it is coming out, flux keep on decreases. So that kind of graph will come for the variation of EMF across the loop. Now the next question, a wire of length 50 centimeter. So length is given 50 centimeter, moves with a velocity 300 meter per minute. Instead of second, they have given minute. That means by 60 meter per second, nothing but 5 meter per second. The EMF induced in the wire is 2 volt. So EMF given as 2 volt, that equal to BLV. Now they are asking magnetic field. So magnetic field equal to epsilon by LV. So epsilon is 2. L is 50 centimeter means half meter. V is 5 meter. So that is 4 by 5. So 4 by 5 means 0.8. So what is the magnetic field? 0.8 Tesla. Now one last and final question. A 10-meter wire, so length is 10 meter, kept in east-west direction is falling with a velocity 5 meter per second, perpendicular to the magnetic field, 0.3 into 10 power 4 Weber per meter square. The induced EMF. So it is also direct question. As I said, simple formula based questions you just try to practice. Sometimes they may also mention like with respect to horizontal component of the magnetic field. So when a rod is falling under the effect of gravity, due to the horizontal component of magnetic field also, the EMF will induce. So that question also they can ask. So this is how you need to solve the questions based on motional EMF and the power dissipated. I have given the example questions based on the same thing. So please just try to solve it. And I have also given the NCRT based questions as usual. So lot many questions are there. See, 7 questions are there. So you can understand the importance of this topic. So please solve all the questions and we'll continue in the next session with the next question. Thank you.